Hey, this is an overview of technical devices that we use on a day-to-day basis. So in this class, I'm going to go over PCs, routers, switches, as well as servers, and kind of break things down and try to make sense of all the terminology that we have been using over the past couple of weeks. So I'm not trying to be long with this video. I'm trying to make it hit the main points, and that's basically covering these topics: the motherboard, CPU, memory, such as RAM, your hard drive, the operating systems, what are servers, kind of dive into IP addresses and the ports that servers and computers use, as well as we'll finish up with the directories. So what is your PC? Your computer is a device that receives information and carries out commands. The way it does that is by having what we call a motherboard installed within it. So either you have a laptop or you have a desktop. Either one still has this green circuitry board here that you see on the slide, and that's called your motherboard, and that's where all the processing happens and all the inner workings take place. So on the motherboard we have what we call the CPU. The CPU is called the central processing unit, and think of this as the brains of the computer. The CPU will take in information, and it'll either dish out information or it'll compute any kind of commands that it receives. Okay. In the conjunction of that, you have what we call memory. More specifically is RAM. So that's random access memory. With RAM, is more of a short-term place that the CPU can make the decisions of what commands it needs to take out. So it's a short-term memory bank. It just uses the RAM for the time period that is actually on. So with that being said, you can't store files here. So whenever you make kind of like a Word document, it's not going to be stored in your RAM. It'll be stored elsewhere, and we'll get to that in a minute. But your RAM is going to be there for short-term memory only, and whenever the power is cut from your PC, your RAM is cleared, it's cached out. So just keep that in mind. With longer storage of things that you want to be able to save even if power goes out, that's where we have our hard drive come into place. So these are where you're going to be storing large files, data that's sitting on your hard drive. That's why you want more of a hard drive. You want your hard drive to be a bigger space to actually fill up and actually store those files there. So now that we know that we have a CPU and we have a motherboard, we have the brains of our PC, we need to understand how does our PC communicate with the user? How does it communicate with you? And to know how a computer communicates with each other is by seeing the picture that's laid out here on this slide. So that is what you call binary bits, and it's basically just ones and zeros. 0 is equivalent to being off, and a 1 is equivalent to being on. All right, and in machine learning, that's how PCs and desktops and servers communicate with each other. So of course we can't read that as humans, so we need something that is translated and we're able to see, and that's where the operating system comes into the play. And operating system, we have, everybody's familiar with it. Either you have Windows, Mac OS, Android for the phones, and Apple iOS for iPhones. So this is a simplified way that humans are able to communicate to a actual PC and actually send those commands and those instructions that create data for the PC to actually take in, and then it can act out on those commands that we want them to execute. So now that we know operating systems, and we know that whether it's a desktop or a laptop, that we're going to have, basically the same internal organs on a PC, let's talk about servers. Servers are basically supercomputers sitting out there on the internet that's willing to give a function of whatever it is out to whatever client. So it's serving a function to you, me, to another server, to another application, wherever it may be. These are pretty heavily boasted PCs that serve different functions. They can serve different functions, or they can just serve one function, and that's all that it does. It could be just a storage bin, and then we just pretty much just put files in and store things up. But that's no more than what a server really is. I also, under this topic, I wanted to dive into IP addresses. And so the way devices talk to each other is through IP addresses. So whenever you're connected to a network, you're assigned an IP address, and it typically looks like what you see here with the 31.13.64.7. And that is a way for other devices, other PCs can send traffic over the internet to a particular server, a particular PC, a phone, a tablet, anything. So this is how you get your identity on the internet. It's kind of like having a house address for your own particular device. And so we have these numbers here separated by the 3 dots to represent each device. But again, it's kind of hard for humans to remember, those 4 digits for every different website that we wanted to go to. So we also created something called a domain name system. And DNS is how we take those IP addresses and then we associate them with the readable human form of words to associate it with. So as I got here, 31.13.64.7, it translates into facebook.com. If you were to copy and paste, or just kind of go to your copy and paste that IP address and put it into your Google Chrome, you should be able to reach Facebook that way. And so just kind of wanted to introduce IPs that way, where let's keep in mind that whether it's a server, is your own personal PC, it's your phone, your tablet, whether it's your smart car, your smart car that connects to the internet, they all get a IP address. And that's how we send packets back and forth. And we'll go over packets in the next slide. So now that we are in the network phase, we're going to be dealing with packets. And this is what our servers and our desktops and our laptops and our phones, they're all sending back and forth, is packets. And in order to send these packets back and forth, on the network, we need something to control the traffic, to tell the packets where to go and then where to return back to. And that's the job of the router. So as you see here on the diagram, the router has different arrows pointing different types of ways. So it's a traffic director, right? And it knows how to communicate to other routers. And all these routers are placed out throughout the internet, and they direct your packet, your traffic around the internet to these different servers. All right, gathering information from that server and then returning it back to your PC so you can see it on your screen. So In the security field, we also need the firewall to sit in front of the router and block any traffic that may be malicious or unwanted traffic that we don't want to go out. We need to block that traffic there. So that's why we have a firewall. In a lot of cases, you will see the firewall and the router being the same device. Okay, but in this case, this is a physical, actual device that gets on the network. It obtains its own IP address. It's its own entity, and its sole purpose is to serve as a firewall, reading rules, letting packets in or letting packets out. All right, so let's move on and let's look at this. Let's dive a little bit deeper into packets and then network protocols on how they actually communicate. So when you send things back and forth, when I'm saying we're sending packets, could be a picture. Let's say a picture of this slide. What it actually happens is that, you know, when you attach it to an email and you want to send that email to your friend, data is broken off into little bits, as you see in that image right there. Is broken off into little bits, and it's sent across the network. And when it gets to your friend's computer, those bits are rearranged back up into the actual picture or the slide that we originally started off with on the beginning side. Okay, so every time we send things across the network, it is broken down into these little packets. That's why you hear me harping on TCP and UDP. Those little packets, TCP will want to have every bit of those pieces put together in order to make the whole image. Whereas UDP is not necessarily necessary that I get every bit of it back. All right, so that I kind of jumped the gun a little bit to go into network protocols, but network protocols and ports are the way that different devices, different servers, PCs, we communicate on the network. They set up these standards of this is how we're going to talk to each other. Okay, so your server is not necessarily smart enough to just understand any kind of nuance. It wants to have a structured list of commands and needs to follow those things out. So this is where network protocols come into play. And when you connect to facebook.com, it says, you know, you send your first packet out and say, hey, I would like to go to this IP address, right? We go to the IP address, Facebook pulls up. But before it pulls up, it's saying in the packet, hey, before I communicate with you, we're going to communicate on using HTTPS, all right? And we're going to use that as our communication protocol. And in order for me to use that protocol, we need to come in on the port number for HTTPS, all right? And that's the lump sum, a very high view of how different devices connects out to a server, and then they set up that initial communication packet, and then they decide to communicate that way. So finally, let's talk about directories. So back onto your personal PC, or even a server for that matter, but let's stay with the personal PC. Whenever you log into your OS, your operating system, you'll see folders, and nine times out of 10 those folders have files within them. We can create them whenever we feel like them, and we can place them wherever we want. So you'll see some in the my documents or my pictures. You can create a new folder and name it security plus class, and these are what you call directories. These are pretty much separation of folders for file organization purposes only. The reason why we stress on it in the security field is that, you know, different files may be sensitive to personal use, or in a case of your business, may be sensitive files within the business, and so we need to make sure that we have the permissions set on these things straight. But I just wanted to really kind of give the overview, since we're kind of talking about the basics of computing, that the directories are ways we can organize our data in a sense that we can, us as humans, we can see it and then we can understand where it's at. So just to wrap things up, I just kind of wanted to bring this performance-based question back up, and let's take another look at how the firewall rules work. And I just want you guys to really just look at the diagram, understand that everything here has an IP address, and don't get confused on things like internal network and then the cloud out here with it being the internet. The internet is not a cloud. It's not a destination to get to. It's being able to be routed to another PC, another server, another device. That's all it is. And so don't let that be a confusing point for you. Just know that when we're writing firewall rules, we need to allow or deny. Are we gonna tell somebody to come in, or we're not gonna tell somebody to come in? How are we going to communicate TCP, UDP wise? What protocols are we gonna use? Are we gonna make sure that we get all our packets that's broken down and sent to us, or is it okay if we drop some? Where's that source IP? Now again, we explain the IP. Everybody has an IP. Everybody has an address. Okay, so we just want to make sure that we pick the right ones for the rule to follow. And then the source port. And remember, ports are how we communicate. But on the same tip, I can't tell you what port to communicate on. All right. But if you're coming to my domain and you're coming to my server, I can tell you, hey, in order for you to get the functions from my server, we're gonna communicate on this port using this protocol. Okay. So I just wanted to bring that back up and just kind of break those things down. I hope that this kind of clears the air about some of the questions that you guys may have of the technical base of it. Let me know if we need to do more videos like this, and I'll try to make some up and put them out there in the class. Okay, thank you.